Hello and welcome. If you enjoyed this video, make sure to hit the like button, JK Auto Review, share it with your friends, and subscribe. Today we take a full technical dive into a next-generation air dominance concept. We'll cover every major subsystem, the airframe and stealth features, cockpit and avionics, propulsion and thermal control, sensors and electronic warfare, weapons and drone teaming, operational roles, logistics, and known limitations. I will explain technical terms as we go. Let's begin. Visual overview. Show multiple angles of the aircraft. Slow 3D pan, close-ups of canopy, leading edges, intakes, twin tails. This design blends stealth features with an aerodynamic planform that looks optimized for long-range missions and sensor fusion rather than pure dogfight maneuverability. Airframe and low observability. Narration. The overall shape is a low observable blended fuselage, smooth curvature, minimal right angle intersections, and serrated edges on control surfaces. These choices reduce radar cross-section (RCS) across X and Ku bands. The wing is mid-sweep with a blended root, leading and trailing edges are aligned to deflect radar. Control surfaces appear split and actuated via multi-surface arrangements to manage signatures and maintain control without large exposed flaps. Notice the buried or S-shaped engine inlets and inlet covers. These reduce direct line of sight to compressor faces, key for radar stealth and IR management. Twin canted tails are small and set to reduce high aspect reflections. They can also house electronic components or conformal antennas. Technical note. Stealth trade-offs. Very stealthy shapes limit internal volume, fuel, weapons, avionics, so designers balance external geometry with mission endurance. Suggested on-screen text. Stealth, shape plus materials plus edge alignment. Cockpit, HMI and automation. Narration. The cockpit likely integrates a single large panoramic display with sensor fusion, radar, EO/IR, threat warnings, and friendly target tracks fused into a single tactical picture. Helmet-mounted display (HMD) or augmented reality visor to cue missiles, targets, and waypoints. Highly automated systems. Adaptive flight control, auto-target suggestion, automated mission planning, and high-trust autonomy for teaming with UAVs. This reduces pilot workload and enables mission effects as a system leader. The design suggests a single pilot configuration. However, future variants could be optionally crewed depending on mission needs. Production tip. Show HUD overlays and animated sensor fusion demo for the viewer. Propulsion and thermal management. Narration. Engines appear embedded, a stealth choice to hide hot turbine faces and reduce IR signature. This complicates cooling and exhaust management. Typical solutions include mixed flow nozzles, infrared suppressors, and coolant channels. Expected performance envelope. Long-range cruise fuel efficiency with capability for short bursts of supercruise or afterburning when needed. Exact thrust, top speed, and service ceiling will be speculative. Trade-offs. Embedding engines reduces drag and signature but increases maintenance complexity and may reduce internal fuel volume unless compensated by conformal tanks. Suggested visual. Cutaway schematic showing buried engine, serpentine inlet, IR suppressor. Sensors, EU and network architecture. Narration. Modern NGAD concepts act as sensor fusion hubs. Expect an AESA radar possibly distributed across the airframe, IRST, infrared search and track, for passive detection, and advanced EU, electronic warfare, arrays for jamming and deception. Data links and tactical networking. Secure, low-latency data links allow this aircraft to share tracks with fighters, AWACS, ground stations, and unmanned systems. That creates a distributed sensor and shooter package. Software-centric systems. Modular, upgradable software stacks permit capability growth via updates rather than hardware changes, a vital strategic advantage. Cybersecurity. Hardened architectures, encryption, and resilient comms are necessary given reliance on networking. On-screen caption. Sensor hub. Radar plus IRST plus EU plus datalinks plus software. Weapons, internal bays and unmanned teaming. Narration. To preserve stealth, primary weapons are likely carried in internal bays. Expect combinations of long-range air-to-air missiles beyond visual range, active radar and dual-mode seekers. Short-range high off-bore sight missiles for close engagements. Air-to-surface precision weapons. Small-diameter bombs, standoff cruise missiles, anti-radiation missiles for SEAD. Unmanned teaming. This aircraft could control or coordinate multiple loyal wingman drones, using them as remote sensors, decoys, or weapons carriers. Drones extend reach and reduce risk to the manned platform. Modular payloads. Weapons pallets or mission kits allow fast reconfiguration between air superiority, strike, and electronic attack variants. Visual suggestion. Animate bomb bay opening, missile racks, drone detach. Mission roles and tactics. Narration. Primary. Air superiority, air dominance, detect and defeat adversary air threats at long distances using networked sensors. Secondary. Strike, seed, dead, suppression, destruction of enemy air defenses, and acting as a command node for combined manned-unmanned operations. Tactics: operate at standoff ranges, detect before being detected, hand off targets to long-range weapons or drones, use EW to blind or confuse enemy sensors, and maintain layered defense with allied assets. Example engagement flow: the aircraft detects a target with passive IR, classifies with fused data, hands coordination to drone to position for attack, and launches long-range missile while jamming enemy radars. Logistics, sustainment and industrial considerations. Narration: advanced materials and coatings for stealth require specialized maintenance, low observable glow coatings, edge treatments, and sensor recalibration. Embedded engines and complex cooling raise turnaround time and specialized depot maintenance. Cost implications: stealthy, software-rich aircraft are expensive to procure and sustain. Designers mitigate by modular systems, commonality across fleets, and software upgrades. Industrial base: long development life cycles, supply chain for advanced composites, avionics, and secure software teams are critical. On-screen facts: low maintenance cycles, depot repair, software updates. Threats, vulnerabilities and countermeasures. Narration: vulnerabilities. Stealth does not equal invulnerability. Low observable tech is optimized against certain radar bands and conditions. Bistatic radars, low-frequency radar, and passive detection IR, visual, can still detect signatures. Reliance on network links is a target for jamming and cyber attacks. Complex systems increase logistical and sustainment burden. Countermeasures: multispectral sensor fusion, radar plus IR plus passive RF, reduces single-point detection. Advanced EU suites, deception, and emission control (EMCON) help preserve survivability. Distributed force posture, using drones reduces single point of failure. Comparison with current fighters and strategic outlook. Narration: compared with 4th 4.5th Gen fighters, NGAD emphasizes sensor fusion, stealth, and networked warfare over raw close-in maneuverability. Compared with 5th Gen F-22, F-35 likely follows similar stealth principles but pushes deeper. On modularity, software-forward architectures, and unmanned teaming. Strategic value: advances in networking and software upgrades can extend the platform's relevance longer than hardware improvements alone. Conclusion and outlook. Narration: this concept points to the future of aerial combat, a blend of stealth, sensors, software, and drones. It's as much a flying command node as a weapons platform. The real impact depends on engines, software maturity, integrated logistical systems, and budget. If you're curious about a particular subsystem, engine designs, AESA radar differences, or drone wingman tactics, comment below and I'll make a detailed follow-up. Call to action: and ring the tell me which part you want next. Weapons loadouts, cockpit walkthrough, or a comparison video with X aircraft. If you enjoyed this video, make sure to hit the like button, JK Auto Review, share it with your friends, and subscribe.